So I'm going to spend a few minutes tonight just kind of talking about scaling. I've spent about 20 some odd years, which makes me feel really old, in the Valley, working on various enterprise software companies, Sun Microsystems back in the good old days, working on operating systems, working on application software, a little bit of hardware, worked on scaling teams, groups, and companies in some cases. And so I thought what might be useful is to take a look at some actual examples of the things that tend to go wrong, because you learn your most from your mistakes. So I'll go through a few of those, talk about some of the challenges that I've seen just personally, and hopefully that'll help you guys to maybe not do the same thing I did in a few of those cases. We'll see how that plays out though. So there's going to be sort of three main themes here for important factors in trying to scale. So one, obviously, is going to be technology decisions. These are the actual technical and architecture decisions that you're making, both in the early stages, and these evolve as companies grow. And so you need to be cognizant of the challenges that you're setting up for the future as you make these decisions. But equally important to these are a couple of other areas that people oftentimes overlook. One of those is people and culture, and the impact that that has as you try to grow an organization, especially if you're trying to grow one rapidly. If you're not thinking about your culture and how it plays in your organization, you tend to run into some pretty serious people problems. And then the last one we'll touch on a little bit is engineering process. So what is the value of process? What are the things to think about when you're trying to create a process? And how can that help you to grow and build a strong company as you move forward? So before we get into that, I thought it was worth stealing one slide from our user experience team. And that was making sure that before you get into scaling your startup, it's a really good idea to know that you're building something that people actually want, right? So do you actually understand what the situation is that your customer is in? What's motivating them to make a decision to purchase something? And really important is, what do they think the outcome is going to be? Not what you think they want built. What do they actually want as an outcome from you, right? If you don't understand this, you're not scaling. You're still at the starting blocks, right? You're still trying to figure out what to build. So if you dig into that a little bit, you should be asking yourself, do I have a clear problem statement? The elevator pitch. Do I know in a few sentences exactly what problem it is I'm solving and for whom? Am I solving something that people actually want solved? Sometimes you have a great idea that nobody actually cares about, and it's good to figure that out quickly. And the other one is it something that you can truly monetize? Are people going to pay you for this? Do they see enough value to pay? Or do you have to go a different route, like an advertising-based route, in order to get revenue in against the idea? They think it's great, they're just not willing to pay you for it. But enough people use it that you can use ad revenue to make your business successful. A couple of other things worth noting here. Different customer types will have totally different expectations for the software that they're using. If you're doing a consumer-based application, those expectations can be kind of low in certain cases. Clicking on a button twice isn't that big of a deal, right? If you're looking at enterprise class customers and you're trying to get into, say, financial services or banking customers, they have a whole different set of expectations. Many of which have nothing to do with your features. They have to do with security audits. They have to do with processes they expect you to follow. They have to do with your source code living in escrow so that they can take it if you have a problem, right? And they can then use it moving forward. So you got to understand who is it that you're building things for, so that you know what kinds of hoops and hurdles you're going to face as you try to build out that company. And then the last one here is pretty important, which is beware of premature optimizations. So I think a lot of folks are probably on the engineering side of the various houses here. One of the challenges on the engineering side is you see a problem and you want to solve it, and you want to solve it the right way the first time out of the gates, and you want to kind of polish that rock a little bit, and that can slow you down dramatically. So we'll go through a few examples of these kinds of trade-offs where going slow and doing a clean, clear job on something would have just made you late enough to the market to not succeed at all, right? So you have to take into account sometimes those shortcuts are incredibly valuable, and you will pay for them later anyway. So there's no avoiding that in the end. All right, so let's walk through each of these just a little bit. So let's talk about technology decisions first. The first thing is change is sort of constant. You need to be able to move very, very quickly. That first idea, that first piece of implementation you do oftentimes isn't actually quite right, but it leads to that conversation that pushes you in a new direction. So open source software is one of the great ways to very, very quickly prove your ideas out, right? I can just go download something from the internet, I can go plug together a few of these components, and generally I can show real progress for people pretty quickly, right? The one thing to remember about open source software is it's not actually free. In your customers' minds, if you're now using that, it's yours, you own it. And if it's not working, you have to fix it, and you have to fix it quickly. So if you're going to use open source, it allows you to prove those concepts out fast. But I've been in multiple situations where we used a piece of open source, and we found those bugs that were in there somewhere, because let's face it, just because somebody else wrote it doesn't mean it's perfect, right? It's got bugs just like any code that you would write. And when we started tripping on those bugs, and in this case we were in the enterprise, those customers came back and demanded fixes for that open source right away, right? In a very, very short time window, which meant we had a pile of engineers that were now desperately trying to understand somebody else's code that they were reading for the first time. So the thing to keep in mind with open source is it'll prove those concepts really quickly, but you got to remember you own it if you're using it. You now have to be able to support it. You can't just assume that you can send mail to the community and somebody will be your hero and jump in. It doesn't always work that way. That's especially true if you use a component of open source in a way that's a little different from the vast majority of people. And that has definitely happened to many, many people in the past. Other thing here is cloud solutions. Cloud solutions are great. Why? Because it used to be that you would go buy a physical server, for example, and now you've got to have somebody who's maintaining the server, somebody that makes sure that you have enough servers to support your workload, and so on and so forth. So the cloud lets you kind of throw that problem onto somebody else, like DigitalOcean, for example, right? Now you can focus all of your attention on the software stack you're trying to build. You can also download components from these software vendors who are giving you cloud components, and now I've got a whole set of building blocks I can use. So the one thing to watch out for is vendor lock-in, right? Those components are enticing because they speed you up just like open source would speed you up. They have the benefit of support from the cloud vendor, which means, oh, now it's not quite like open source because I can actually call them and complain, right? But it makes it much harder for you to move to somebody else if you become unhappy in the situation you're in. So it's something to keep in mind as you're looking at cloud vendors is your ability to move and the ability to have a solution that can work across cloud vendors that gives you a little bit more ability to be flexible as you go forward. The other one with respect to cloud is cost management, right? The fact that somebody is providing you that infrastructure and that layer, they're making money off of that, which means that you're paying them a fee to do these things. And in the cloud in particular, a lot of the pricing models are crazy complicated, which makes it really hard to predict how much you're going to spend as your business starts to grow. And what you don't want to find out the hard way is that as your business grows, you lose more money, not make more money, because of the cost of running all those components in the cloud. So there's a whole startup ecosystem around figuring out how much your bill is going to be at the end of the month, right? That tells you how complicated it is. There's dozens of companies that do this as a specialty across the cloud vendors. So one thing to do is think about what are the components you need, what are the kinds of flows you're going to have, model it out a little bit so that you really understand if you have a viable solution. And what are the kind of changes that would impact your ability to actually be profitable off of those vendors, right? There's definite trade-offs in these areas. You want to invest in development infrastructure. In every major project initiative I've been involved in, the best engineers on the team always go do infrastructure work first. They're not writing interesting, fun code. They're doing the deep, hard work of setting up CI/CD pipelines, of automating some of the infrastructure creation scripts. Those things buy you tons of time later. Right? They're really terrible to bolt on after people have already gotten in the habit of delivering code in the way that they want. So it's super important that you actually take those things and do them first. Oh, we got a candidate there. The usual Stucky is somebody's always the person who jumps in and does that, right? They kind of do the hero's work. And it's really, really valuable. The other piece not to forget is observability, right? So you go back to the open source software component idea, right? If you don't build in observability, the ability to debug what's going on in production, you're going to be lost the first time something goes south. How many of you are trying to do things with microservice-based architectures? Lots of little services running around decomposing problems. It sounds great until you try to debug it in production, right? Now you have 12 or 14 different things talking to each other at random, and you can't figure out who's doing what when, right? So if you don't build some of these frameworks in place, you're asking for trouble later, right? So those are some of these trade-offs that are really, really dangerous if you're not careful. Building out high leverage common components. As you start growing an organization, there's no reason to have 3 different implementations of the same thing from 3 different groups, right? As soon as you get beyond that 10-person team, somebody else starts doing something similar that you could have done in one place and shared it across teams. So thinking about those open components that you can share across your teams can buy you leverage later. It's one thing to debug instead of 2 or 3 of the same basic functionality, right? I've had teams that had 2 or 3 different database backends for 2 or 3 different parts of the system. So one, it made your software really fat, right? And 2, you didn't actually need 3 different databases. You were just trying to store data and people picked 3 different ones because they weren't talking to each other, right? So these are things just to kind of keep in mind as you're structuring things and getting yourself started. So people and culture decisions. So I put on the right here, actually, these are DO's cultures. These are our core values. We actually have these painted on the wall, actually, at headquarters in New York. You want to be able to go and explain to people what the company is about, internally facing. What is it that the culture is that you have? Consciously decide on it, communicate it, make sure people are aware of it, You want to invest in that. That culture will attract the kind of people you want that share those cultural values. And if you hire people that are not aligned with that culture because they didn't realize it coming in, these cultural anti-patterns are super disruptive, right? It's the sort of the classic no assholes policy that a lot of groups try to have, but they don't really do it. And then one comes in and it ruins things for a lot of people, right? So you want to actually consciously think about your culture and how you want it to be structured. Along those same lines, how you're organized really matters. It determines how teams are going to behave. Understanding what is the role of an engineering manager versus the role of, say, a tech lead. Do you have a management ladder and a technical ladder that people are climbing? If you don't clearly state which of those things you're following, you will have confusion between those two groups, and then you just create friction amongst the team, where you have people competing with each other because you weren't clear on what those roles actually meant, and the team got confused, which is kind of a natural thing. Another warning here is be careful what you measure, because it really drives behavior, right? I've seen this, at VMware at one point, we had a support engineer, and the measurement for success of the support folks was the number of calls they captured per hour and closed. And it turned out that if you hung up on someone, you closed the call. So this person hung up 5 times in a row and then went and got coffee because he had met his quota. Right? Now, eventually that person was found out and fired, which is probably the right idea. But again, you have to be careful what you're actually measuring because people will react to it. If you stand up in a meeting and every time you have a meeting, you start with running through the bug list and talking about the defects in the code, people will spend more time fixing bugs. If you stand up and you start every discussion with where are we on our velocity, how fast are we delivering features, are we meeting the needs of our customers, that's where people are going to go focus their attention and their time. Right? So how you behave, the things you talk about, those are the things that people are going to model. And if you're measuring it and you have the stats on it, they will focus on making those stats look better. Right? So it's a powerful tool to use on teams for good or bad, depending on what you're up to. And then lastly, I think you really need to be able to accept and make trade-off decisions. You need to be able to stand up and say, I'm not going to go fund this because I can only fund one of the 2 or 3 things on the list. We're going to fund this one, and then we'll get to these other ones later. A lot of times people will try to say, we'll do all 3 of those things, knowing they can't possibly afford it. They don't have enough people to do the 3, but they really feel bad. They don't want to say no to anybody. So they hand out a little bit of headcount to each of these teams and grow the teams a little bit, and none of the teams got enough to be successful. Right? It's a classic sort of failure mode. Stand up, make the decision, fund the one effort, do the other 2 later. Right? You have to be willing to make the hard calls. Otherwise, you're just hoping, right? And hope is not a strategy. All right, and lastly, the sort of hear no evil, see no evil, say no evil. Process isn't actually evil, right? As teams grow in size, engineering processes become a really important factor in being successful, especially as you scale up significantly. So it's not really a bad word because for the most part, a lot of these engineering processes are just common sense. Should I get a code review from somebody else before I check my code in? Yeah, that seems like a pretty good idea, right? Should I have tests that I've written and automated so that I can validate that my code works? Probably a good idea. Is it a good idea to bounce your architecture off of somebody else? Yeah. Is it a good idea to document the design and put comments in the code? Sure, right? So when you're on a really small team, all that stuff is common sense because those are conversations that are just happening all the time. As teams get bigger and more distributed and less coupled, they're more loosely coupled, process is what kind of helps guide people down that right path. It helps force some of these knowledge captures, drives technology selection. It helps codify what's been going on historically and drives a common set of values and behaviors moving forward. So it really should actually be pretty straightforward for folks. If people are complaining that they're jumping through hoops for no good reason, you've probably done something funky with the process side of things, right? Because if it starts feeling that way, it probably is. And so this can really help a lot in just kind of taking a team and helping it grow fast, which is what I think everybody would like to get to when the startup is having that hard problem of needing to hire 50 people fast, right? If you're not ready with some form of process, some way to onboard those people, you're going to struggle with it as you move forward. All right, so that's the basics. So let's go through a few examples. Let's talk about it in a little bit more detail, perhaps. So one thing is there's these S-curves for innovation. Has everybody seen the S-curve models before, right? So these are kind of a classic these days, right? And the idea is that over time, you have this sort of maturity that's occurring on the technology, and it's going to kind of dwindle over time, and you want to build up the next set, right? That's the basic idea behind the S-curves. And effectively, you're growing up into the right like any good chart, right? And it's easier to draw that than it is to do it. So if we go to the next slide. Let's walk through an actual example of one of these situations. So I was at this little company called Virtual Instruments. It was a startup. We started about 6 engineers, grew to 150 pretty quickly. So when we started, we had a hardware and software-based solution. We were very focused on the enterprise, right? So the high end of the enterprise, so banks, insurance companies, general financial institutions, trading houses, folks like that. Our whole goal in life at the beginning was to monitor and troubleshoot SANs, right? Storage area networks, and the systems that were tied to them. Today, that company is now spread out across the bottom here, doing a whole series of other things, right? So how did they follow the S-curves? If we go to the next slide, let's take a quick look at how they kind of fit in. So if you click once there for me. So wave one in this particular case was this high fidelity storage monitoring, right? So it's a hardware and software solution that would let you look at every transaction occurring between a server and the back-end storage that supported it. So you could see timing, behaviors, errors, things like that. It was a really good troubleshooting system, right? Wave two was we need to get multi-protocol. We need to add devices. We need to provide analytics, right? So lots of feedback coming in from customers that effectively said, this is great, but it's really an expert's tool. What we want is more analytics, and we want you to cover these devices that even if we don't have them today, we might buy them at some point, right? So that's one of those classic things that customers will typically do is it's the checkbox item. They may be locked into storage area networks for like the next 50 years, but they'll never want to admit it. So they want you to have all those other kinds of storage that you could support just in case, right? So you got caught up in trying to do some of these things. And then the next wave was building application awareness. So now I want to be able to start looking at application information as it flows all the way back into the storage network and be able to give you end-to-end flow information, right? So that's the sort of nirvana that they work their way towards. So the key here, if you click there for me, is in the middle. The transitions between these waves really matter, right? So what happened in this particular case is at the start, this section was actually pretty clean as a POC. It was not pretty clean as an enterprise scaled architecture. So what ended up happening is we went from largely test dev focused trials where customers tried it out and loved the results to them wanting to deploy it with 6,000 ports behind the scenes when it had originally scaled to 4. Right? So all of a sudden you had the classic, ooh, that's not what we thought. But that's great news because if you want 6,000 ports and we charge a lot of money per port, we're going to do fantastic, except that it can't work that way. Right? So this gap was really a whole bunch of hard architecture work to rebuild the entire bottom of this stack, to make it scale with a database that would actually scale for the needs of the product. A middleware tier, right? All these pieces had to actually work in ways that they weren't designed to work to begin with. So that left us with this gap where we had already started to go down the descent, right? Where people were realizing, hey, it's not scaling for their needs, right? And so they would just hold off. So then you also run into the problem of this next one as it starts ramping up, it's net new, right? It's a new data model, it's a new data store. All the pieces look different, it feels different, right? So you stalled the entire customer pipeline. So you had existing customers who weren't ready to move forward because it felt totally different. Looked great, but they were gonna wait and see, right? And this ended up building out off of net new customers first. Now the good news in this scenario was once you got through this piece, you had the ability to go very quickly from tier to tier after that. Because now you had the right foundation that you could scale off of. Adding application awareness was just one more piece on the existing architecture. So you kind of sorted it out at that point. But it was a real struggle doing that first transition because the timing was off. And it's something to kind of keep in mind. This is back to the thing I said at the beginning. We were polishing some pretty serious rocks in that transition that we probably could have got away with not doing, right? Let's look at another example. I spent a couple of different stints now at VMware. So VMware did some interesting things, right? So as a company, they started out really test dev focused, right? So the whole premise behind VMware at the beginning was you've got Windows, you've got patches coming out on Windows. The compatibility is not fantastic on patches or versions, which means people's software kept breaking, right? A patch would come out and your software would break. So ideally, you wanted to be able to go back and say, I need to test my changes against all these different versions of Windows to make sure that there aren't any incompatibilities across them, right? That was the premise behind some of the early virtualization work there, right? So it was a test dev product. You would install it on a PC. I could now run 10 copies of Windows next to each other and just run my test suites against all 10 at one time. So it was a massive time savings. So the next wave in the S-curve was to take that into the server and say, well, if the same thing applies at the server tier, now I can run 10 different workloads. And most of the time, the CPUs in these servers were largely not that busy, right? You have spiky behavior, so I can add that in, right? So they ran up the S-curve using the same base technology, right? Then you started layering software on top of that, right? So now you're in the IT shops and you're adding things like backup and high availability, and you add other solutions that start allowing them to customize internal IT apps, right? So you start building more and more things up to today where there's a major focus on hybrid cloud and doing things in the cloud from VMware's perspective. So they were able to go through and execute these S-curves by actually even stacking some of the S-curves and having multiple of them running at the same time, and grew that to a 20,000 person company with pretty good results. There were some challenges along the way. In the early days, the management stack was rewritten 3 times in a row, right? Why? Because the requirements just kept changing radically, right? So first it was the add-on. You can have some management with that too, right? But then it became, now it needs to scale. So when you went from test dev to server to taking over whole data centers, your scalability factors went sky high, right? Not only that, but you're now monitoring a massive footprint with a huge volume of data that wasn't there before, right? And so that ended up spinning some things up. The other piece here was the success of this business really required this separation of focus, right? Each of these teams had their own mission that they were on. So if you had one organization all focused on sharing across all of these things, it would have been chaos, right? So they created the business units. The great thing about business units is each one of them has their own thing they're driving for, their own success criteria they're managing to, but they're tribalistic in nature, right? They don't really talk to each other, right? Their goal is to make their BUs successful, right? So when you want to do things across BUs, welcome to, like, I mean, you think governments are complicated and slow moving? Try going across BUs, right? Because they're designed to be successful in this vertical focus, and they're really, really good at it. And it requires tons of coordination to actually cross that boundary, right? We used to always say it's easier to partner with somebody outside than it is to partner with the BU in the building next door, right? Because it's just structured in a way that's super successful, almost too successful in some cases. Oh, another interesting one. So I spent about 10 years at Sun, actually. So Sun and Veritas was an interesting combination. So Veritas was this little company, kind of out of nowhere, that built a file system and a volume management solution. So now I'm in the way back time machine here. What was interesting about that is they took advantage of all these APIs that they could see coming out of the operating system, that at the time did not have a great file system or volume management solution, right? So they were hugely successful in doing that. The problem was they were using a whole bunch of internal things that nobody realized they were doing, which also led to quality issues, panics in field, all sorts of problems, right? So we ended up trying to do this partnership, and what you had was this heavy engineering-driven culture that had a very, very thick, rigid process, right? Where there was actual like legal contract language used around APIs and things to ensure that across 35,000 people, things would work correctly, right, as they evolved. And then you had this startup where in the first meeting we had, the question was, well, what do you do if you have to make an incompatible change to some of the APIs? And the lead engineer at Veritas said, I open the door and I yell incoming, and everybody knows if I yell incoming, it means I'm breaking everybody, and they all have to go back and figure out what I did, right? And you compare that to Sun, where it would have taken months to go through that process to verify every single change and what you were allowed and not allowed to do, right? So what we ended up doing was sharing some of that same contract language externally, right? And working with them to ensure that we could actually provide API support that wouldn't change underneath them and vice versa, right? And ended up actually rolling Oracle into that whole mix and having one view for database, file system, volume management, and operating system as a means to help customers not see finger pointing between vendors, right, which was a big piece of the challenge back then for those 3 companies. So lastly, I think it's probably worth taking a quick look at DigitalOcean. So I've been at DigitalOcean not for terribly long, only about 4 months now, in fact. But if you look at the history of DigitalOcean, you can kind of see the journey that it started to go on, right? So back in the early days, our droplet create rate was relatively low. As we got into Techstars and started switching over to SSD to provide higher performance, we started seeing significant uptake. We started doing some market comparisons, got a little bit of press, and actually each of these little spikes there was specific press articles, as it turned out. All of a sudden, you felt like you had the right fit, right? So you had the right pricing, you had the right product, and you started scaling up. So that worked great, and then what you don't see just off to the right is when it went up 100x, right? So when it really took off, it really took off. And everything managing this was a single monolithic app on a set of hardware that was deployed specifically to scale to a certain level, and all of it broke, right? So it's one thing when you have a single monolithic app with a single data store behind it, and you've got a data center. It's another thing when you have 12 data centers, but everything runs through one, and everything touches the same database table, right, to coordinate. And then you start adding on to that you need to track every single event that changes any of the behaviors of a droplet because you have to have that history, the transaction history. And you're locking the table every time you do that. So when you take this and you multiply it by 100, 200x, all of a sudden things got really, really slow for a while, right? And those were technical decisions that were made early on. Having that one simple table, man, it took like 20 minutes to get from 0 to this first bit, right? That code came out super fast, right? If you look at how fast they were able to stand up the hardware, super fast, but they made a bunch of assumptions about the networking that made it fast, right? Fast until you got to a certain scale, and then you could not actually go above that, right? So each of these things were decisions that were made along the path. Did that work out? I would argue it did, right? Worked out great. All of those had to be revisited over time. So one of those keys on that process step I was talking about was revisiting by demarcating a line. I know when I get to this scale, I have to start revisiting this. The challenge is when you get surprised by it, right? When you don't know how far you can scale, you don't know what trade-offs you made in the architecture, now you're in trouble because what ends up happening is you wait for it to break. And then it's all hands on deck and everybody has to jump in with both feet and try to figure out what's wrong and how do I fix it, right? That's kind of the worst time to be doing that. So the basics here that we covered off, I think the scaling challenges, they hit everybody in different ways. It really depends where you are, what you're solving for, who you're solving that problem for. That will determine how you make each of these decisions as you kind of move forward, right? It's going to be different for everybody. If you look at the general issues themselves, how important is it that I go fix that single database table as an example? Turned out not that important for the first couple of years, right? It was fine. You could make that work. Eventually, the importance got to be critical because now you have a stall, right? Which is what you want to avoid. Understanding the limits of your tech, but also your org. Know when and how you're going to react to these situations. What happens if all of a sudden tomorrow you close a round of funding and you can get those 50 extra people you want? Can you hire 50 people? Can you onboard 50 people? What happens to all the senior folks that you have on board today? Are they going to now spend the next 6 months training everybody else and getting super frustrated doing it? Maybe, right? So these are the kinds of things that you just need to think about as you're kind of trying to scale up and drive things forward over time. So with that, I'll take questions if there are any. I don't know, I'm actually going to hang out for a while too, so happy to talk offline if people prefer that, either way. Yeah?
Yeah, so one of the things with simplicity, I think, is like not adding that extra button or not adding those extra menus and all that kind of stuff. In the start, you can get the team around, know why you're not adding stuff, but how does that scale when you are like split up between different teams, different products, and then you sort of, everyone wants to add new features, but maybe the total package, loses the simplicity.
That is one of our big challenges because as Mohan was mentioning at the beginning, right, what do we focus on? Simplicity. It's the 80-20 rule. Yeah. I know 80% of the people need this and they don't need that other 20%, but to add the 20%, I get to give you 10 different knobs you can twist, buttons you can push, right, all the rest of that. And again, if part of your culture is that you value the simplicity, then people test each other on that function, right? If you don't have that as laid out and everybody knows simplicity is what matters, then it doesn't work out that way. The other thing is, remember I said, know who you're targeting as an audience. If you're targeting high-end enterprise, they aren't actually always looking for simple. They really want those controls because they've got enough experience in many of these cases where they've seen those really specific 20% and they want a way to control it. And they actually want all of those things. They're willing to give up simplicity to get that extra couple of features that they're after. So some of it is this balancing act between who you're actually targeting and what you're valuing in simplicity. To get off the ground, the simple almost always works better, right? Because that's how you prove that concept out. Any other questions? Yeah? Yeah, that was really interesting. Thanks a lot. You spoke a lot about droplets, and you showed the growth of droplets and adoption of droplets. I'm wondering about the managed services. Is that included in the droplets as well? Like, what's the adoption and growth been for the managed services? So the question, if you couldn't hear him, was just he was asking about managed services besides just droplets. Droplets was the core thing that the business started on our VPS, right? Virtual private servers. And so most of the method we've used for charting is growth of droplets. Some of the things that we build today are built on droplets, and so they generate droplets as a part of what they actually do. So for example, if you use a managed database, it uses a droplet. Right? If you're going to run Kubernetes, it's running in a droplet. So in most of our cases, droplet is a good proxy for scale for us, which is why we use it that way. Any other questions? Yeah?
Any plans to have a
A data center in Hong Kong. So we have one in Singapore. That's probably about as close. I don't know if it's closer to Singapore or is it closer to Bangalore? Probably closer to Singapore, right? Yeah. Not at the moment. I mean, we're always looking to test demand in different markets. And so for the most part, we look at latency as the key measure for the different workloads that we have in markets. I've gotten a lot of requests for Australia. I know Shiv is back here somewhere. He runs our product management team. So he's always listening to hear where people want data centers from a demand perspective, because that's certainly an area that we've looked at as well. But no plans today. Yeah.
On your timeline earlier, you said that as soon as you got into Kickstarters, it kind of ramped up a little bit. And then I saw a really big spike in January of 13. What happened there? And then just kind of...
Yeah, so that was the first piece of publicity where there was an article that was doing a bake-off, and we looked really good in the bake-off. I mean, we were really good, just to be clear. But we also, I mean, it was a really powerful piece of publicity for us. It was the first real press that we had gotten as a company. It showed that we had really aggressive pricing and very, very good performance, right? By moving over to SSDs and things, we ended up with very high performance at a very low cost, and that's what drove that market fit. So that was the big jump that you saw, was the first of those articles, and there were a couple others that came after that drove some of the other spikes as well. Good. I hope you enjoy the food. Thank you guys for the time. Appreciate it.